Let's start with this odd looking lens, which has 3 straight sections on both sides. I'll draw a straight line through the center, which I'll call the principal axis. As a ray of light comes along the principal axis, it hits the lens at 0 degrees, 90 degrees to the surface, so it just carries on straight through. A ray travelling parallel to the principal axis, but up here, hits the lens at an angle. I'm going to draw a continuation line like this, which is where the light would have gone if there was no lens here. I'm going to draw in the normal line, using a protractor to mark 90 degrees, then joining it up. The light is going into the glass, so the ray bends towards the normal, like this. At the second surface, I'll draw the continuation and the normal, and the light this time bends away from the normal, like this. If I draw another ray, again parallel to the principal axis, but below it this time, I'll get the same thing happening, but the other way up. Now, you see here all 3 rays went to the same point. And this is how a lens works, by focusing all of the light to one point. If I make my lens curved, very carefully curved, just the right amount, I can make it so that all the light goes to that point. This point is called the focal point, or the principal focus. And the distance from the focal point to the center of the lens is the focal length. From now on, we're going to assume our lenses are really thin and that they behave like this. So, we don't need to draw the lens and the refraction every time. We just draw the principal axis, the thin lens, and the focal point. Since light behaves the same in both directions, we can draw a second focal point on the other side. For reasons that will become clear, it's also handy to label 2F as well. So that's a lens, and you can now see how putting it near paper so that the parallel rays of light from the sun converge at the focal point on the paper concentrate a lot of energy in one place and can cause a fire. For other uses, for lenses in glasses or cameras, you need to be able to draw lens diagrams with precision. Let's start with the principal axis. A lens, F and 2F labelled, and an object over here, an upright arrow, further than 2F from the lens. There will be an image created by the lens, so let's find out where it is and how big it is. Light will come from the tip of the object in all directions. Now, I don't actually care about all directions, I only care about 3 of them. Parallel to the principal axis, because I know that any light parallel to the principal axis will be refracted by the lens through F. Through the center of the lens, because I know that any light going through the center of the lens will continue straight, without deviation. And going through F on the same side, because, well, you'll see. as the light hits the lens, it turns to go parallel to the principal axis, like so. Looking in reverse, the light would be parallel to the principal axis, then hit the lens and go through F. If drawn carefully, you'll find that all three rays go through one point, which is exactly where the tip of the image will be. The base of the image will be on the principal axis, so I can draw the image in. Done. Describing the image, I can say that it is inverted, diminished, on the opposite side of the lens from the object, and real because the light actually goes there.